So how do we compute disparity? Let's take the simple example here, and we know disparity is in essence the difference of XR and XL. We need correspondence, which basically means is in both those images, I need to know exactly the locations XR, and it's the same point that should be visible in the other image. In essence, what we need is each pixel or any pixel has to be corresponding to the other pixel in the left image. So any point that's in the right one should also be appearing in the left one. Now, of course, we have learned how to do feature matching and stuff like that already. Of course, you can imagine that any point I find in the right image, I can search for it and match for it in the left image. And many different methods we have looked at, including even just simple correlation methods and normalized cross-correlation methods that we've looked at, could be used to find a feature in one image and find that same feature by doing, again, as I said, what cross-correlation does is basically a inner product or a dot product, and we'll find the most similar pixels. Computationally, you can imagine this gets to be pretty complicated. Similarly, the other method we can actually do is sum of square difference measure errors. Take any pixel or region or neighborhoods. Remember the kinds of stuff we've looked at already when we talked about just neighborhoods of pixels and how to do kinds of filtering and comparisons. Well, that all could be applied here. But you can imagine this is going to get pretty complicated if I have to do pixel by pixel, region by region matching, and also perhaps at different scales. To help us, we can actually rely on something called the epipolar constraint. Basically, that says is you don't need to search the whole 2D image when I actually found something I want to match to from the left to the right. Basically, what it does is it reduces the search space to one-dimensional line. Let me show you what that means, but the idea really remains is, in this case, there is no change in the y-axis. So why should I search for everything that is in this point across the whole image? I should search for it just across that line. Remember the interesting things about stereo imaging, right? Both eyes are on the same y-axis. Most of the time we want to use that constraint for two cameras on basically being at the same axes.